All right, everyone, we know how to solve systems of equations by using graphing. Now we're going to move into a few algebraic methods, the first of which is substitution. So we're going to learn today how to solve systems of equations by substitution. Substitution is not new to us. We've been doing it since we started doing algebra. So, for instance, in this example, evaluate the following when x equals 6. To solve that, to solve for y, you need to substitute 6 where you see x in this equation, right? So we have x equals 6, means every place we see x in this equation, we substitute 6. 3 times 6 plus 4y equals 12. 18 plus 4y. Subtract 18 from both sides, we get 4y equals negative 6, and y equals negative 6 over 4, or negative 3/2. And likewise, we're not always solving for y. Sometimes we solve for x. So let's find x when y equals 2 for this guy. 2x plus y equals 10. Now we're substituting 2 every place we see y. So 2x plus 2 equals 10. Subtract 2 from both sides, we get 2x equals 8. Divide both sides by 2 and we get x equals 4. So this is what substitution is at its crux. The difference is we're going to be substituting entire expressions instead of just a value. So, now that's not the only difference. Here we have a system of equations. I'm going to call this equation number 1 and that equation number 2. First step is to write an expression, a substitution expression. Whoops. So the best way to do that is to set one variable equal to, or to solve one of these equations for one of the variables. I like to find an equation that has one of the variables without a coefficient, or with a coefficient of 1, because that's just going to be one less step. So I see in equation number 1, there's a coefficient of 3 on x and a coefficient of 4 on y, but in equation number 2, y has a coefficient of 1. So I'm going to just rewrite equation 2 and solve for y. So I'm working with equation 2, and 2x plus y equals 10. To isolate the y, I just need to subtract 2x from both sides of the equation, and I get y equals negative 2x plus 10. Well, just like in the previous problems where I had, y equals 2, now I have y equals negative 2x plus 10. I can substitute this whole mess wherever I see y in the first equation. So let's do that. And then we have an easier problem to solve. So now I'm working in the first equation. I have 3x plus 4 times my substitution, which is negative 2x plus 10. Negative 2x plus 10. And that all equals 12. Now I have one equation in one variable, and I can solve for that variable. So we get 3x plus, I multiply 4 by negative 2x, that gives me negative 8x. 4 times 10 is 40, and that equals 12. I combine like terms, I get negative 5x plus 40 equals 12. Subtract 40 from both sides, negative 5x equals, what does this give me? Negative 28. And I get x equals 28 over 5. You can put that in a decimal form, but you don't need to for my class. Now, trouble is, we want a solution to a system, and system has two equations because it has two unknowns. we have found